Hi everyone, welcome to part one of a two-part series on measures of variability. In a previous episode on measures of central tendency, we first saw this tent metaphor, and we learned how measures of central tendency are kind of like the tent posts in the middle, all right? They tell us about the middle of the tent, something about the location of the middle of the data, all right? The middlemost, okay? And we learned about the mode, the median, and the mean, all right? Well, now we're going to turn our attention to the spread of the tent, all right? So measures of variability tell us a bit about the flaps of the tent, how wide the tent is, all right? A tent can be tall and skinny, or it can be short and fat, or in between. Okay, so I want this to be our metaphor for thinking about variability in data. I want you to be able to visualize it and think about it visually. All right, so we're going to be concentrating on the spread of the data now in measures of variability. Measures of central tendency we learned way back when, all right? And they're good, they're quick, they tell us about the middle, and we always like to know about the middle, all right? When you get exams back, you like to know what was the average. Everybody always asks what the average, but you also likely then asked questions about, hey, what was the high score? What was the low score? Depending on where you might have been, all right? Particularly want to know those, hey, did I get the high score? Oh no, I hope I didn't get the lowest score. Okay, well, measures of central tendency are great. We love them, but they're limited, all right? So one of the foremost things about behavior, right, is that it's variable, all right? Everybody's different. People don't behave the same. People don't behave the same way time after time, all right? So if there's one thing that's unvarying about behavior, it's that it varies, okay? And it varies by varying amounts. So that's what we're going to be turning our attention to now is um, some measure of that kind of variability. All right. Now, this should feel old and familiar to us now, but let's take another quick look at this. Again, I like to think about statistics visually, so always be thinking about distributions and how they look. I mean, we look at the data. I tell you to plot the data, to look at graphs, to, don't just rip into formulas and measures of central tendency and measures of variability like monkeys with cupcakes, all right? You pause and you take a look at the distribution. And so we are going to be concentrating quite a bit, as you'll see, on normal curves. And they deviate from normality by concepts of skew and kurtosis. Okay, they can be tall and skinny, short and fat, or medium like this one here. Or they might be distorted. In positive or negative skews. All right, so anyway, we learned all this. We covered kurtosis and skew in previous presentations. So refer back to that if these concepts are still a little bit fuzzy to you. And we also learned about multimodal, bimodal, trimodal, quadrimodal, multimodal distributions. And, sometimes there might be a couple of modes or more modes. Okay. And we learned, of course, that there were other shapes. There's an infinite number of other shapes, and we looked at a few of them, and I gave some examples here. So all of that and all of this is about visualizing the distribution, all right? So particularly as we concentrate on normal distributions, we're going to be referring to how tall and skinny, short and fat, or how medium the data seems to be distributed, all right? So always be thinking about that, but be thinking about the tent as we turn our attention now to measures of the spread of the tent. Okay, so the 5 measures of variability that we're going to cover in this and in the next presentation are these. We're going to quickly go through the range and the interquartile range. And then we're going to turn our attention to getting some mean average deviation, some mean measure of the amount of deviation that we're going to see. And I'll explain that shortly. All right. We'll talk about something called the variance and the standard deviation, and those will be our measures of variability that we cover. All right. So in this presentation, I'm going to just talk about the first couple here. So the range is the simplest measure of variability that there really is. The range is just simply taking the highest value, subtracting the lowest value. The high score minus the low score gives you the range, all right? If you want to know the range of temperatures for a city, okay, here in Honolulu, we're blessed with temperatures that are very moderate and don't vary much from about 80, 85 degrees, right? On any given day, even in the summer, the highest record recorded temperature might be 90, 91 degrees perhaps. in winter days, in particular, our winter days in particular, we might get record lows of 57. Oh my God, if it got to be 57, I think the state would close. Okay, people would go into a panic if it got to 57 degrees in Honolulu. All right. So anyway, if we could imagine that a record high temperature on a given day might be 90 and the record low temperature might be 70, the range of temperatures might be just 33 degrees, 90 minus 57. I'm from Stevens Point, Wisconsin, and this is a little exaggerated because this wouldn't be in one day, but in the summer it can get crazy hot. It can be 110 degrees in the summer on a July, perhaps. Okay? My personal record low temperature that I've ever experienced was minus 59 degrees Fahrenheit. Okay? I remember that number very well because I was driving school bus at the time. When I was in college, I was a school bus driver. And even if you're not from a nice cold climate like Wisconsin or Norway or somewhere like that, you can probably at least imagine what snow days were if you've never experienced a snow day. Yes, getting so much snow that it's unsafe and schools are canceled so that parents and bus drivers like me didn't have to risk their lives getting stuck in the snow and so on. So anyway, everyone prayed for snow days, right? Even when you were a grown-up, you would pray for a snow day, all right? Well, we theoretically had something called cold days. Now, I never experienced personally a cold day. We never reached it because in my district, the cold day was called when it would be minus 60. So I was driving school bus and it was projected to be perhaps a first ever cold day called for the next morning, and like all the kids, I went to bed and woke up and you would turn on the radio when you were expecting a snow day or a cold day and pop on the radio first thing when you woke up to find out, they would list this, the following schools and businesses are closed, and they would read them off, and you'd sit there and all of a sudden you'd get really religious and pray really hard that your school or your business was announced as closed. All right, so I got up that morning, turned on the radio. They said the temperature was minus 59 degrees. All schools in the district are open as planned, as usual. Oh my God. So I had to go drive a school bus in minus 59 degree temperature. I can tell you that's cold, all right? I don't wish that upon any of you. I might have mentioned this little side story here. I can remember a February that did not get above zero. Not a day in February, not a week in February, an entire February that never rose above 0 Fahrenheit. That's cold. So anyway, this wouldn't be in one day. We would never have a day that's 110 or a day that's, the same day of the year that would be minus 59. So anyway, we might think of this as maybe Stevens Point's, range of temperatures, okay? 110 minus 59 is a range of 169 degrees, okay? So compare that range of temperatures with Honolulu's, range of 33, and you can see a lot more variability in temperature up there in Stevens Point than here in Honolulu. Okay, well, that's the range. The advantage of the range is also its primary disadvantage. It's based entirely on just two scores. Now, 110 degrees is pretty extreme. It's not like we have 110 degrees up there very often, and as I just said, we don't get temperatures like minus 59 very often. I've had only one day in my life that was like that. So it's a little bit exaggerated, a little bit extreme. It's not very typical to say that in a typical year, the range of temperatures up there is 169 degrees, okay? So the range is simple and quick, but that's also its disadvantage. Sometimes it's a little bit too quick, a little bit too sensitive to extreme scores or extreme data. Okay, take another quick look. Okay, if I took a sample of students. Okay, these are their ages in one class. So my highest age in this class is 23, and the lowest age is 18. I would have a range of just 5 years. Okay, one particular semester I had a 79-year-old woman taking the class. And, now the range was from, 79 to 18, a range of 61 years, okay? Now let me make one last point about the range before I move on. The range, technically, okay, if I ask you what the range is, the correct answer, if I say what's the range of ages in this class, the correct answer is not 18 to 79, okay? You finish the math, you subtract. 79 minus 18 is 61. The range is 61 years. okay? So don't forget that. When I ask for a range, I'm not asking for the two high and low scores. I'm asking for a single number that reflects that. So do the math, okay? So that's the range, okay? It's quick, it's simple, you know, it's like asking in class, what was the high score, what was the low score, okay? A class might have somebody that just goes off the charts and gets all the extra credit points and has a score of 110% on a test, and then there's sometimes a student that just didn't really do any of the work, any of the studying, any of the reading, any preparation, and they come in and absolutely tank it and get maybe a 20%, okay? And so those might be just two students on polar ends of the spectrum there, and so you can see how the range can sometimes be accurate, but sometimes exaggerated because of extreme scores. All right, so the next measure of variability is, I'm going to present it, here it is, and this is the last we'll probably ever talk about it, but it's out there and I just want you to know of it. So one criticism of the range that I just said is that it's sensitive to extreme scores on one or both ends of the scale here. So a compromise, particularly if you have big data sets, is to compute what's called an interquartile range, okay? Interquartile range. And basically all you do is you shave off and throw away the top 25% of the scores and the bottom 25%. In other words, you get rid of the top quarter and the lower quarter, and you just look at the two remaining quartiles, okay? It's a little misleading. It's not the interquartile range. It's like the inter-half range. It's the half of the scores that are left after you got rid of the top 25% and the bottom 25%, okay? So the range from the top of the 25% to the lowest, of the, you know, to the, anyway, that inter-half range there, okay? So it should be maybe called inter-half range, okay? So you're definitely not going to do this with a small number of numbers. I mean, if you've got 10 numbers, and even if you think, you know, the bottom end or the top score is, you know, extreme, you know, to shave off 25%, you know, getting rid of 50% of your data when you only have 10 numbers would be a little bit extreme. So you would only do this when we have very large data sets, okay? So I'm not going to, I don't want to waste too much time talking about it because we're never going to use it again in this class. The one place that we may see it here, and you may run into it in the future. The most likely place is in graphs like this. So this is sometimes called a box plot or box and whisker graph because you have boxes with whiskers. Okay, and so this is taking advantage of the interquartile range here. So let's pretend that we had males and females watch a chick flick, all right? I think the chick flick in question here was Bridget Jones's Diary, if you've ever seen that, a true chick flick if there ever was one, okay? And so we were measuring, this is a pretend study, pretend that we measured physiological arousal while watching the film, okay? The males and females were strapped up to electrophysiological recording equipment, testing their blood rate and you know, blood pressure and heart rate and galvanic skin response and stuff like that, okay? And we might get something like this, okay? So a box plot has kind of a lot of things going on here, okay? Let's kind of work our way inside out. The heavy line in the middle is usually the median, sometimes the mean, okay? So these two lines represent the middle, you know, the median or the mean. To be honest, I don't remember which one. I'm pretty sure SPSS uses the median here. So let's just call these the medians, okay? So these were the median, you know, amount of arousal. Now notice something kind of interesting. The male arousal level is higher than the female arousal level, okay? So we could already sort of make the claim that males get more aroused watching chick flicks than the females do, okay? What does that mean? Does that mean they actually like the movie better? That they're actually more, you know, is arousal necessarily equated with liking something? No. Okay. They could be more aroused because they could be sitting, you know, they could be angry. All right. You get physiological arousal to happiness, to anger, to fear, to sadness. Okay. Generalized, your general response is a generalized response, and you know, your heart rate and blood pressure go up whether you're really angry or really mad or really sad or really anything, okay? So maybe they're really mad that they got to sit there watching the movie with their girlfriends or, you know, wives, okay? I don't know. Or maybe they actually do like the movies better. I don't know. But the fact of the matter seems to be that males have higher arousal during this movie than the females do. Anyway, that's the heavy lines there in the middle, the medians, okay? The box then, the heavy gray box then, is that quartile. All right, so we've shaved, the program has shaved off the upper 25% of the scores, going up to here. This represents the highest score, the highest amount of arousal, and this represents down here the lowest amount of arousal, and in between there in the box is the bottom 25% of the scores, okay? So it shaves off that bottom 25 and that top 25, and the gray box in the middle represents the half that's left, the range of the half that's left, okay? And likewise for the female. So males seem to have a little bit more arousal to this, but their arousal was a little bit more compact, a little bit more homogeneous, a little bit more alike, less variability, okay? Kind of tilt your head sideways and you can kind of see the spread of the tent here, okay? All right? So females had a little bit more spread, okay? The peak arousal was about the same for males and females, but the level of arousal for females was quite a bit lower than the lowest level of arousal for males, okay? So the females were much more spread in their arousal and tended to be a little bit less aroused on average. Okay, so anyway, there's a box and whisker plot or box plot, okay, and it takes advantage and takes advantage of the interquartile ranges. So that's about the only place that you're going to really run into the interquartile range. It's not very frequently reported as a number itself. Okay, so we move on. All right, my goal now is I'd like a better number. Okay, the range is problematic. The interquartile range isn't really a great solution. Nobody really likes the idea of throwing away half of their data. My God, when you start collecting data, you'll understand that. You want me to what? Throw away half of my data? Are you kidding? How hard and how much time I spent, collecting data to throw away half of it? No way. People don't like that interquartile range very much. And so anyway, the range is problematic. We want something better. So we love the mean. We love the mean. We had that, we've been calling it the average all of our lives. We've had it since we were about 10, okay? And it's a nice simple number that tells us about the middle of the tent. Well, now I'd like a nice, simple, snappy number that represents how much spread I've got, okay? I'd like to know, okay, what's the average spread, okay? Let me say that again. I'd like to have a number that represents the average spread or the average deviation, okay? Every score deviates by some amount from the middle of the tent, okay? Some scores are higher than the middle, some scores are lower than the middle, some people might be right at or even precisely at the middle of the tent, okay? And so everybody in the data set varies from that middle by some set amount. They have a deviation score. So what I'd like is the average amount of that deviation, okay? I have the average itself right there in the middle of the post of the tent. Say that again. I got an average already. The tent post is a middle amount. What's the mean score on this test? Boom, right here in the middle. Okay? Well, everybody varied from that mean by some amount. Even if you varied by 0 from it, even if you got the average score on the test, okay? You had a deviation of 0 from the middle. If you had the highest score, you differed by the most, the highest on that end, okay? If you had the lowest score, you had, your deviation was the biggest deviation in that direction, okay? So what I'd like now is to take all of those individual deviations, take everybody's deviation score, and get an average of them. Does that sound like a great plan? I think that sounds like a great plan. And at the end, I'll have 2 means to report. Here's the raw mean, here's the mean score, and now here's the mean amount that people differed from that score. Say that again. The average deviation would then represent the mean amount that the people differed from the mean. The mean amount that they differed from the mean. Okay? So that's where I want to go with this. I'd like to get an average deviation, okay? So in the next episode, we'll take it from there, all right? So in part 2, we'll continue to explore this goal. Let's try to get the average amount that the people or the scores differ from their mean. The mean amount that they differ from the mean. That's our goal next time. Thanks. Nice short one. See ya.